Hey, welcome back. This is Max Made Easy with AB, where Max and you becomes an inseparable bond. So, in the previous video, we were discussing about cross product. In this video, we shall discuss about relations. So, as the name suggests, you would have framed the definition for relation. So, before going into the definition of relation, let's actually understand it from the view of cross product. So we took set A to be 1, 2, 3 and set B to be 4, 5, 6 in the previous video, and we found the cross product, that is the possible number of ordered pairs between A and B, and we plotted in the form of graph. So I would like to remove certain elements from this graph, and I get 3 points like 1, 4, 2, 5 and 3, 6. So I collect these 3 into a set called as R. So let me name that set R, and I write those corrected elements into this set. Okay, so I have this set R to be 1, 4, 2, 5 and 3, 6. So for each B in the ordered pair, that is here, if the ordered pair is 1, 4, and if you name 1 as A, then B is going to be 4. And if you name 2 as A, B is going to be 5. And if you name 3 as A, then 6 is going to be B. So for the ordered pair AB, we have B equals A plus 3. That is, B is some way related to A. In this case, B is related to A by increase in 3. That is, if you take A as 1, then your B will be 4. That is, 1 plus 3 equals 4. And if you take A as 2, then 2 plus 3 equals 5. That's going to be your B. And if you take B as 6, then A would be 3. That is, 3 plus 3 equal to 6. So this is what we called as relations. That is, A and B are related to each other. So as a real life problem, let's take the family. Let's consider this family. So we have Matthew and Smith, who gave birth to a son and a daughter named John and Mary. So Mary marries Jones and raises 3 children, Alice, Alvin and Agnes. And again John marries Kalpana and gives rise to Caleb and Sharon. So let's consider yourself as Agnes now. So Agnes is related to Mary as mother, and Agnes is related to Alvin as elder brother, and Agnes is related to Alice by elder sister. So if you cross product Agnes with the elements inside the family, Agnes is somewhere related to each and every other people in this family. So we say that as a relation. So likewise, if we take Sharon, Sharon is related to Caleb as his brother, and Agnes is related to Caleb as cousin. So you can find a number of relations just from this family example. So I think I made relations very clear, and let's get deep into it. So we shall take another example too, like y square equals 16 times the element x. The value for y would be the square root of 16x, that is nothing but plus or minus 4 root x. So if you, let's take the element x to be 0. So for x equal to 0, y becomes 0. So we have the ordered pair 0, 0 here. And for x equal to 1, you have y equals plus minus 4 times 1, which is nothing but minus 4, and plus 4, which is nothing but you have 1 4 and 1 minus 4 here. And if you take x equals 4, y is actually equal to plus minus 4 times 2, which is actually 8 and minus 8. So x and y are related to each other. So this is what we call as a relation. So let's learn some of the new definitions which are actually very important in learning relations or the next topic, functions, because these words play a vital role in learning mathematics. So let's get used to that words. So domain of NAR is nothing but the set of all elements x which belongs to the set A, such that if x and y are related by a relation R, for some y belongs to B. That is, the collection of all elements in set A which is actually getting mapped is called as domain, which is actually used in the relation are called as the domain. The codomain is nothing but the whole set where the answer is considered is called as the codomain of the relation R. So in this case, the codomain is nothing but the whole real number line, and the range of R is nothing but a subset of codomain where you get all the y elements in the relation. So here 0, -4, 4, 8 and -8 is the range for the R, and the domain for the R is again the whole real number system here. So for whole the real number line here, and the range of this relation is nothing but the answers for which you substitute for x is the range of R. So let's actually look on some proofs in relations. So let n of A equals P and n of B equals Q. That is, the cardinality of set A be P and cardinality of set B be Q. Then the number of relations from A to B, from the set A to B, is 2 to the power P times Q. So let's prove it. We are given n of A, that is cardinality of set A is P and cardinality of B to be Q, and we note that the number of elements inside the cross product of A and B is P times Q. The number of elements in the cross product A cross B equals the number of elements in A times the number of elements in set B. So as said the property, we actually write the number of elements in A cross B equals P times Q, or simply PQ. And also we note that relations is the subset of a cross product. In the first example we saw B equal to A plus 3, we removed certain elements from the cross product. Since we removed certain elements from the cross product, the relation R becomes a subset of the cross product, and so relation is a subset of cross product. But how many relations can you form from that cross product? The relations are nothing but the subset of the cross product. So the number of relations between A and B is nothing but the number of subsets you could form from the cross product, which is nothing but 2 power PQ. And we shall discuss about null relation now. So null relation is nothing but a relation which does not contain any values. For instance, let me take A to be -3, -2, -1 and B to be 1, 2, 3, 4. We define a relation from set A to set B to be defined as A minus B equal to 8, where the element A belongs to set A and element B belongs to set B. So pause the video and check out what are all the pairs A and B you could find, so that their difference is going to be 8. So glad that you have paused the video, or no problem. Yes, so as you brainstormed that there are no pairs A and B such that A difference B is going to be 8. Thus, the relation R does not contain any element, so R is going to be an empty set. When a relation is an empty set, that's going to be a null relation. So let's summarize what we have learnt in relations. So relations are nothing but the subset of cross product where the elements inside the ordered pair is related, somehow related to each other. Definitions, so we saw the important definitions like domain, codomain and range, and we also saw about null relations which can also be existed, and the number of relations between the set A and set B could be 2 to the power n of the cardinality of A times the cardinality of B. Hope these videos are making your 10th standard studies better. Let me know in the comments if you find this channel better than your max teacher. Tata, bye bye, take care, see you in the next video.